What is happening, Webster Groves? This is 8th grade science chemistry goal 8 video notes. Let's take a look at what you need to know. So, meeting the goal, meeting the expectation, you are able to explain how matter is pure or mixed. Okay? So, pure substances and mixed substances, you're going to need to know both of those things. You're going to need to identify a substance as a mixture. This will include knowing how to separate it. Okay? So, knowing the difference between a pure substance, a mixed substance, and if it is a mixture, knowing how you would separate that mixture. If you're going above and beyond meeting the expectation, achieving a level 4, you are able to do what is at a level 3 plus compare and contrast a heterogeneous mixture, and you're able to classify mixtures as homogeneous. Okay, so you're able to know the difference between hetero and homogeneous mixtures, and you're able to look at a mixture and classify it as one of those types of mixtures. What does it mean? Well, let me tell you. Okay, well, what is a mixture? A mixture is any substance that can be physically separated. So, physically meaning you are manipulating it yourself. You can physically separate the pieces. A pure substance, quite the opposite. It's pure. It's pure. It's a pure substance. Any substance that cannot be separated or can only be separated by chemical means. So, for example, water would be a pure substance. It can only be separated by chemical means. My cereal this morning would be a mixture. Okay, can be separated by a physical means. Moving on. So, how do you know if it's a mixture or a pure substance? Well, I'm so glad you asked. You know because it can be physically separated. It's a mixture. So if you look at a substance and you can physically separate out the pieces of what it's made of, then it's a mixture. Well, how do you know? You know if it follows one of these, or there are several other methods for separating a mixture. You could sort things, you could evaporate, you could use filtration, you could use magnets, you could use chromatography, chromatography, screening. Those are just some of the ways you could separate a mixture. So what does that mean? Well, sorting, this is the kind of thing you do with your socks and your t-shirts. You sort things, you put them into categories based on what they look like or their physical properties. Okay? So you can see what I'm doing right here. I'm just sorting things by color. So this is one way of separating a mixture, just by sorting. Okay? It's kind of a duh. We get it. Moving on. Evaporation. What? I didn't know evaporation could be used to separate a mixture. Well, now I do. So evaporation, it's going to take the liquid water out of whatever mixture it is. So, for example, this pond here, all of the water is being separated out of all of the sediments and everything else that's in there. Evaporation is also used in the method for distillation. If you look at this picture, you can kind of figure out what's going on. Okay, so here we have a mixture. Okay, it's a solution, so that's water mixed in with some other chemicals. It's being heated, so the water is going to evaporate out, and then it travels into this tube where it gets cooled, and so when water vapor gets cooled, it turns back into a liquid, and it travels down the condenser tube and into the receiving flask as a liquid. So the liquid has been separated out of this solution. That's distillation. Okay, that's that method for separating a mixture, distillation. It's a method used for separating liquid from a solution. Filtration. This you're probably pretty familiar with. You have a filter, you pour a substance through that filter. The filter holds on to all of the sediments or the solid particles that are in that mixture, and all of the liquid goes through. This is used in your average coffee maker. Okay, so coffee makers use filtration systems. They have a filter, and the hot water runs through, and the filter holds on to the coffee grounds. Unless you're unlucky, then you get coffee grounds in your coffee. Not cool. Screening. Screening, very similar to filtration, but screening, you have screens, and that just separates out the size of the particles. So these screens are used to separate the particles that are in soil, large, medium, small. So screens can be used to separate mixtures by the size of the particles that they're made of. Magnets.
Here we have a mixture of
okay.
sand and iron. And
I'm
this, mixture unmixed,
gonna mute that guy. So he's gonna show us the sand and magnets and how the magnet can be used to separate the iron filings that are in there out. So that's just iron filings and sand, and he's using the magnet to separate out the iron filings. Iron filings are just like shavings of iron. Okay, so he takes the iron filings out. There's still a little bit of sand in there. It could be run over again with a magnet, but you get the idea. Here's more of a picture representation. You have two substances mixed together. A magnet can be used to separate those things out. Okay, so the magnet is in the bag. Okay, so that's using a magnet to separate a mixture. Another way is with chromatography. Chromatography. So chromatography is a technique used to separate a sample into its components based on the speed in which they move through a material. Okay, so in this picture you have different colors on a filter paper. Okay, so for example, you have like green ink here. Okay, a liquid solution is evaporated across it or moves across it, and once that liquid moves across the ink, the different colors that the green ink is made of separate out, because all of the different colors that it's made of travel at different speeds. So we can see like yellow moved the fastest, that light green color was kind of medium speed, the blue stayed in there the longest. So it allows us to see what this color ink is made of. It's kind of cool. Okay, so that's chromatography. Here is kind of a video representation of what happens. So you have 4 different color inks, and as water is drawn up through this wick, the water moves across the filter paper, and we can see that the colors are kind of bleeding out of those inks, and we can see what those inks are made of. Made of a mixture of different colors. So these inks would be an example of a mixture because they can be separated. Okay, so that's chromatography, and in the end, here's kind of what it looks like. Okay, pretty cool. So level 4, you're going to have to know heterogeneous and homogeneous mixtures. So what does this mean? Well, heterogeneous and homogeneous. Heterogeneous is a mixture where the substances are not equally distributed. So there's kind of different groups within that mixture. Homogeneous is a mixture where the substances are equally distributed. So if we take a look here, let's look at our first 2 examples. We have M&Ms. Okay, yeah, we can see, there's kind of a group of reds here, and maybe a group of oranges over here, a group of greens in the back. It's not equally distributed, and so this would be a heterogeneous mixture because it's not evenly spread around. On the other hand, Kool-Aid, you mix it up and you get a homogeneous mixture because that sugar dissolves into the liquid and it's evenly distributed around. Gotta love Kool-Aid. Here we have a pasta salad. So the pasta salad, you can see, you know, feta cheese, goat cheese. Isn't that a weird thing, goat cheese? That feta cheese is kind of spread around, but there's not too many parts of that cheese there. And so this is a heterogeneous mixture because it's not an even amount, or it's not evenly distributed throughout the mixture. On the other hand, coffee, the coffee particles that are mixed into the water are evenly mixed into the water. And so because of that even distribution, it is a homogeneous mixture. Okay, here we kind of have a picture representation of what it would be like. So here we have heterogeneous. This is kind of we have a group of two different particles, and they're both mixed together, but they're not evenly spread out. On the other hand, this mixture evenly spread out, and the substances are equally distributed. Okay. Something else to know about these mixtures: a heterogeneous mixture is going to have different properties in different parts. So you could have solid properties, you could have gas properties, you could have liquid properties, or they could just have different chemical properties as well, like ability to combust, or ability to oxidize, or ability to float. So different properties in different parts. On the other hand, homogeneous mixtures are going to have the same properties. So once these things mix, they kind of become one. They're one mixture. They're one homogeneous mixture, and they're a little more difficult to separate, and they have the same properties in all parts of that mixture, not just in certain sections of that mixture. Alright, well, that's all, and that's it for the Goal8 notes. Let me know if you have questions, and we'll talk to you later. Bye-bye.